Hello my friends and welcome to Untitled Chapter, the sound Misha. And today we are going to continue to bring this wonderful Nakamichi MR-2 back to life. So we're going to be doing calibration. Please see my previous videos where I was fixing some relays and bias potentiometer, also clean up all this stuff in order to make sure it works nice and dandy. So please stay with me and I'm gonna go through the procedure of calibrating Nakamichi MR-2. So for what do you need for calibration? You need true RMS multimeter in order to measure levels in different spots. You need some kind of interface which would feed the signal to your computer in this feed this to your computer or oscilloscope and audio generator. In this case I'm using Analog Discovery, which is oscilloscope and generator 2-in-1, and also it is connected to my computer in very nice and handy format. So over here there is my laptop sitting right there on the chair right beside me, and okay, after I showed you my setup, let's start the procedure. It was very handy to print out this layout of all potentiometers and test points, also step-by-step procedures. Also some of the voltages here, for example 300 millivolts minus 0.6 dB, I converted right away to millivolts, which can be measured by this guy. Of course, we don't have to forget that we also need calibration tape. This is A&T Audio calibration tape made in 2001. This is type 2 chrome cassette. So it will be used for setting up the azimuth, the speed and the level. So in our manual we have to start with tape speed adjustment, 3 kHz using the frequency counter to output jack. We would use our either multimeter or oscilloscope. I think multimeter will be absolutely fine. So let's power this guy up, load the calibration tape. Yep, not what I want to do. And don't forget to use the right side, not this side, but this side. I'm gonna connect my multimeter to some of the test points, which are very handy. It says output here. We would use that. So we are, I think with that, it's really pretty good. I don't think I have to adjust anything. I think we are very, very nice. Yep, 3 kHz plus minus 15, but we have 3 kHz plus minus 5 or 6, which is very good. I think we stop here. Meter level calibration, next step, step number 2. For meter level calibration, now we have to use the test points. Meter level calibration, we have to input 400 Hz to input jack, put VTVM, our VTVM on this TP101, which is right here, close to this board, right here, and another one is right here. You're going to be using left channel for now, and then do record. So we have to eject this cassette, record, stop. Take any sort of cassette. This is type 1 Sony, I'm gonna put it in, hit record. So this is record mode, but in pause. Then record pause, then we're gonna tweak those two potentiometers, which is right here, if you're gonna obtain necessary levels. So setup is set the output level control to max. So there is an output level control right here on the back. Set it to max. Feed 400 Hz and adjust the input level control to obtain 350 millivolt minus 6 dB, which is 326.6 millivolt RMS. And we have to adjust those two potentiometers to get zero level right here on the meter. So let's do it. So first we have to feed in input signal of 400 Hz. Okay, 400 is in. We have 35 millivolt. We have to make it 350 millivolt. Sorry, 326. Go up. And somewhere here, looks like it's not linear. 300, too much. Oh wow, that's really tricky. I think 322 will do. And make sure that our meters are just starts showing 0 dB. Take the ceramic screwdriver and tweak it like just like that. So go back a little bit and then go forward. Hop. Starts illuminating. So it just starts illuminating. Alright, but this is not over. Now, next step is adjust the input level control to obtain 35 millivolt on the VTVM. Minus 10 times less, or minus 20 dB, which is 10 times less. 335 millivolt. I think that's gonna be good as much as I can. Yeah. Okay. And we have pretty much the same. Minus 20 dB is lit. This is how it's look like. Okay, minus 20 dB is lit. So we're gonna do MPX filter adjustment. So let's try that. So next step is MPX filter adjustment. Step number 3. Apply 19 kilohertz to input jack. 19 kilohertz. Sounds like cool. 19 kilohertz. Set the output level control to max. Adjust the input level control. Okay, VTVM to output jacks. Okay, output jacks. Well, in this case, we're going to be using our analog discovery scope on the computer, because I will show you also with VTVM, but in this case, we're going to be using oscilloscope. So our oscilloscope already connected to the output jacks. Record, pause. It's already in record, pause. Okay, and set the output level control to max. Adjust the input level control to obtain 0 dB 1 volt on the output. Okay, let's see our oscilloscope and just go up and go up. Now when we have this 1 volt right here, okay, let's turn the MPX filter on. It drops to 32 millivolt, which is, that's what it's supposed to be. It says 31.6. Well, it could be even lower, but I think that's gonna be good. So we have to, but if you need to adjust it, let's see. MPX filter, those 2 coils. Okay, we turn on the MPX filter and let's try to adjust L15. Well, it's really hard to get through this bunch of wires, but there's nothing really. Okay, so I can get actually way lower than that. I think this is... Okay, that's pretty low. Okay, let's do right channel. Okay, this doesn't go as low. I think this is as low as it can be. That's perfect. Let's turn it on again. Very nice. MPX filter is definitely working, but I'm never gonna use it because I don't like it. Okay, so our MPX filter is very good. Next step. So the next step is record playback head azimuth adjustment. So we need 15 kHz azimuth tape. We don't have 15 kHz azimuth tape. What we have is 10 kHz azimuth tape from ANT audio. Okay, and the first section is 60 seconds of level calibration. Okay, so on the tape now we found, because it have to be rewind in order to find properly the calibration. So here are how it looks like. So we have to tweak, and this sync is actually looks like this 45-degree as much as possible, like closer to that kind of squished thingy. Here's our azimuth adjustment screw, this one. Okay, so we're going to be tweaking this in order to get as much as possible 45-degree stylogram. Okay, this is our diagram. As you see, two waves are more or less corresponding, and this thing as close as possible to 45 degrees. So this is supposed to give us the best azimuth adjustment. In modern world, I think it's much easier to use oscilloscope than two-channel VTVM. Essentially, you need like two multimeters like that in order to measure those signals. So in this case, we use 10 kilohertz azimuth tape because we don't have 15 kilohertz. But as you show you on my screen capture, that azimuth is calibrated properly. Alright, our next step is playback level calibration. For this we need 400 Hz level tape, which are 400 Hz level tape on this cassette, loaded. Connect VTVM or our multimeter to the test point 101 and 102. We will connect it to 102. Okay. Switch it to volts and playback. We have to adjust resistor 101 and 201 to obtain 300 millivolts on the VTVM. Well, there is nothing to adjust, one channel is perfect. Let's check another. This one is a little bit low. Okay, let's find the correct resistors. Here we are, playback level. These guys. Yeah. So let's tweak this guy. Too much. Wow, it's very, very sensitive. I think this is okay. Let's check another. Stop. Rewind. Play. This is good. And this is good. Okay guys, let's continue to step number 6. So we're gonna do playback frequency response adjustment. So we need few few tapes. Let me show you what I have. So we need 400 Hz level tape. So we're gonna be using this anti-audio tape and 400 Hz. Also, we need 10 kHz frequency response tape, 15 kHz frequency response tape, and 20 kHz playback frequency response tape. We do not have them. I've tried to manufacture these tapes using TDK-SA, and I failed. The level, I recorded them on Nakamichi MR-2 thinking that's we're gonna get the right level. Turned out to be it's not right level. So looks like my Nakamichi MR-2 probably needs calibrating, so that's probably not an option. What I have, I'll show you. Alright, this is what I have. This is Frequenzgang 3.5 Hz to 18 kHz full track a recording, okay, of frequency sweep. So we'll be using that in order to get our cover to 10 to 15. Well, we don't have 20 kilohertz, at least we have 18, can be close enough, and it is at minus 20 dB. So this is second tape we're gonna use. I'm gonna put it to the side right now. Because first, we need this tape. So VTVM to output jack, VTVM is here, but it's connected to output of Dolby. So this is just for reference. You're not gonna be using that. Okay, playback should be set to 70 microsecond, and everything else is off. We will be using type 2 because this is type 2 cassette. So let's just put it on. Power it up, power it up. So what do you have to do? You have to load 400 Hz level tape and play it back. Adjust the output level control to the level, for example, 0 dBV. Pay attention, dBV, which is equivalent to 1 volt. 0 dBV with little tilde on top, 0 dBV RMS is equivalent to 1 volt RMS. This is a very interesting, very useful trick to use 1 volt, because I'll show you why. We can actually use our multimeter here. Multimeter is, that's the play, but we're not gonna connect to Dolby. We're gonna connect straight to output pin right here. And we have one, oops, I'm gonna be monitoring more. 1 volt, one shiny volt. Okay, so we adjust this potentiometer, which is right here, to have 1 volt on output. So now when we adjust it, we're gonna stop. So we're done with this cassette. So now we have to load 10 kHz, 15 kHz and 20 kHz playback frequency response tape. Because we don't have them, we have to use Hans-Peter Ross calibration cassette, which you're gonna put on. So this cassette has 30 to 18 kHz. Obviously, we don't really interested. Oh yeah, this is cassette is 70 microsecond and type 2 as well, which probably uses some kind of this is what it says, MTAC CP, so it's like BASF tape of some sort. Okay, gonna do play. Let's play. So now it is playing. And the tool I'm gonna be using is this, I'll show you. So we will be using Spectrum Analyzer view of a waveform software. So we are capturing both channels, and on Spectrum Analyzer we're gonna see our actually essentially frequency response. This peak corresponds to the level of particular frequency. Frequencies are above and levels are over here. The fact that we picked, you see it's moving, it's changing essentially. Now it's at 2 kHz. The fact that we pick as our reference, as our reference point 1 volt or 0 dBV, that helps us a lot to actually see the reference. And as we see, 4 kHz is precisely at minus 20 dB. Now is 6 kHz. Eight kilohertz. So now we are 10 kilohertz and we are precisely at minus 20 dB, which is great. So we are at 14 kilohertz. So here we are at 18 kilohertz. So essentially this is the last frequency that's going to be on this cassette. It's going to jump and start from the beginning. And looks like our 18 kilohertz is, or was, at minus 22 dB. So, alright, so I think after like looking through all these levels, we are pretty good. So 20 kilohertz minus 2 to plus 4 dB. Well, again, essentially it means at minus 22 to plus 16. Sorry, what I'm talking about. Minus 22 to minus 16 dB. Okay, so that definitely was there. Was like at minus 22. And for IEC 81 standard is actually minus 20. Minus 22, minus 26 dB. Very interesting. To be continued, let's see on what's on the page, second page. If the level for the 20 kHz tape is insufficient, adjust it by referring to playback frequency response adjustment and item 6.2. How do we? Well, it's kind of interesting. They say adjust it, but there's nothing really to adjust. I mean, yes, they are referring, you have to tweak the azimuth. So azimuth is good here, so we're not gonna tweak anything. I think the problem is with step number 6, you have to have these tapes or the tape that I bought, or if you have good cassette deck, like good 3-header, you can actually manufacture this yourself, record the portions of frequency on your cassette and then play this back. That will be very useful to have. So I think we successfully finished step 6. Let's continue. Let's go to step 7. Alright, so I have found CN22. This is the wire of CN22 and it's right here. This is actually erase head connector. So we're gonna switch it to frequency mode. We're gonna use our multimeter right here. And then all these unnecessary bits and pieces. Okay, rack pause, it says. Looks like we need to put some kind of cassette in there. We have this sacrificial cellular in whatever condition we have. Okay, it's rack pause. Alright, so now on this connector we have to measure some frequency. Let's try. It's not easy, but let's try. Okay, well, little correction here. It turned out to be record pause. Okay, does nothing. You have to actually do recording. If you stop, look, I have signal. What do we have? 104. Okay, I have signal. Let me just pause it. We have no signal. That's just, yeah, that's wrong. Where's my red fan? Whatever. So, no track pause, just rec and play. Okay, so we are connected. Now let's try this again and measure the frequency. Unfortunately, it's not easy to. So we were at 1.4, it's 1.5 plus minus 1 kilohertz. It's essentially minus 1 kilohertz. Now let me try to turn transformer. Then I'm using ceramic screwdriver. I turn it one way a little bit. Okay, let's turn it different way. A little bit. And it's gonna be 105. Well, I think it's gonna be good enough. 105. Let's call it 105. Alright, so step 7 is fine. And remember, you have to be and record play. Alright, now we have step number 8, record amplifier equalizer adjustment. So we have to feed 21 kHz minus 20 dBV to input jack. This is interesting, minus 20 dBV. Then apply voltmeter to your TP101, TP202, TP102, TP202, which is here. This is Dolby at the Dolby chip, and okay, same as above. Rack pause. In this case, rack pause is fine, and short the bias cut point indicated in figure 5. So figure 5, bias cut point. It's there is a jumper and potentiometer R317. So top of those guys have to be shorted. I'm gonna be using curved tweezers for this, but I'm not going to be using it now. So I'm already applying 21 kilohertz of 35 millivolt here, which means minus 20 dB, right? Because 0 dB is 350 millivolt at that point, at that test point. All right, so we apply. Now let's switch to frequency. What kind of frequency we get? We have no frequency reading for some reason. Let's see if we're gonna short this and see what's gonna happen. We have nothing. Okay, well, I have allocated those coils. So here is L102 and L202. They just right here, all right, in this area. So it's not enough hands for me, and I'll be using 202 because I'm connected to this coil. Okay, and I'm gonna be shorting, so it's kind of, maybe I should have just used the bridge, solder bridge or something. Okay guys, I still cannot wrap my mind what exactly they're supposed to suggest to do here. So I've done off camera just to, practice myself before shooting. It just doesn't work. So I even attached two, you see the two voltmeters here and just measuring different things, and just, no, I have no idea. Yep. Yeah. 20 kilohertz is only appears when I hit it like at a much higher level. You see? Here we are. It's like, yeah, it's like minus what, 4 or 5 dB. This is something, I don't know, something crazy. Anyways, I'm gonna skip this for now and figure out this later. So step number 8 is question mark. So we going to skip, figure out. So I try to adjust those two coils which are right here, and I just return them back to their original position because they not affect, like nothing was changing. Like when I was shorting, not shorting, nothing was changing. So I decided to skip this. Okay, let's move to step number 9, bias trap adjustment. We're gonna remove the signal from, it says remove signal, remove the signal, no signal, remove input signals. VTVM to TP103, TP203. So TP103 is in this area. So yeah, it's not the best, but it's just right beside the blue coil here. So there is an inductor right here, blue. Yeah, it's really hard to see. Let me highlight that blue inductor, you see? Okay, right here, right nearby. So what we have to do, probably have to do the same, rack, not rack pause, rack play. We have, what do we have? Okay, let's actually switch it to, so we have our bias signal, and now we have to adjust this guy to get the minimum reading, which is going to be this 350 millivolts. So again, I remember how this, so in order to help yourself to understand the orientation, you took this permanent marker, you make a little dot here, right? This give you idea how many turns you've done. All right. Okay, let's see. it's increasing. We have to get the minimum, adjust L103, L203 top the minimum reading. Let's try to get minimum reading. Alright, that actually was minimum reading, so we didn't have to do anything. Yep. So this is already where it's supposed to be. Usually, if no one touched all this and there was no repair done to any of the components of the bias oscillator or record amplifier, not the right spot, I assume. Oh, it's ground. Here. Alright, let's do another inductor. It's higher, let's go smaller. 81. Oh, okay, 371 is the lowest you can get. Not anymore. 372. So only with ceramic screwdriver. If I, for example, would use not ceramic screwdriver, actually it does not really affect much. Yeah, because sometimes if you if you use metallic screwdriver, it affects the reading, so it's really hard to understand what you're doing. But with ceramic screwdriver, it's all not gonna affect the magnetic field at all. So we can tweak a little bit more. 66, 3 point, not too far from the other measurements. So I think this is very good. This was showing the voltage at the recording erase head. Finally, we have arrived to the last step, number 10, record level calibration and recording bias current adjustment. So what do we need? We need source of 400 Hz 0 dB V and 15 kHz minus 20 dB V, probably in relation to this. So if I understand it correctly, that's going to be 1 volt RMS, and this is going to be 100 millivolt RMS, 2 input jacks. We need VTVM and distortion meter. We're going to be using a analog discovery device, which is right here, which is connected to the laptop, and oscilloscope and spectrum analyzer to, I guess, measure distortions. Record, we need 3 type of tape. So we have a metal, oh sorry, that's not metal. We have metal here. We need 2 type 1s, type 2s. So I'm gonna figure out what this is gonna be, and we have Maxell UR, which I have like a lot of them. So I'm gonna be using this as a reference cassette. Also, we need to pick cassettes which are in good condition, like for example, that not mangled, that 2 channels are properly recording and playing back and things like that. Better to use actually new old stock, but if you have new old stock, better to use something which is definitely good. So I picked the cassettes which are in good condition. Also kind of annoyed with this Nakamichi nomenclature that EX is type 1, ZX is type 4, SX is type 2, which is like normal high-end metal, and super annoying. Anyways, obviously we have to switch equalization from 70 to 120 depending on the type of the cassette. So we have to use potentiometers which are in this area of the cassette deck. There are going to be 6 potentiometers in this area which are responsible for, I think they are right here, well, like these guys, responsible for record calibration, and another 6 potentiometers which are on this board here. How they look like, they actually situated right here, which are responsible for bias level or bias current. So we have to start. So adjustments should be made in order of metal, high, and normal. So actually we have to start with metal. The first step is set the bias tune control to use mechanical center position. Alright, it was set. Output to the max. So output is on the back. We have to turn it that way all the way. So like this. Right, so here's the potentiometer. It's in this area. Okay, then load reference ZX, SX, and EX 2. So we start with metal. We load it. Feed in 400 Hz and adjust the input to the level. Adjust the input level control to obtain 0 dBV or 1 volt on the VTVM. Alright, let's do it. So we set it to rack, so rack pause, and now we have to set it to, it is a level here, so it's probably gonna be much higher. So we obtain 1 volt, here is the level on the VTVM. Okay, so then next we have to record, rewind, and play it back. So let's record. Oh, I thought I need to unpause. Yeah, it's very hard with this bright light to see what's the level, but it's actually right up to here with 1 volt. I thought it's gonna be okay. Then we're going to stop. I think that's enough. Rewind and play. So now we have to see what's going on the oscilloscope to understand where we are. And we are having 740 millivolt. So now in order to obtain the recording level that we need, I think we have to adjust potentiometers VR102, VR202, and roughly the same way. Unfortunately, I don't know which way is increase, which way is decrease, so I'm gonna turn them clockwise, so slightly, and repeat the recording procedure. Alright, so finally after like 25 iterations I got to the point that both levels are correct. Also I figured out that every control, like 10x and is left and 20x is right, so like resistors or inductors, this is what in 1 is actually correspond to left and 2 corresponds to right. So yeah, so it's a very good hint actually. Finally I figured this out. Alright, let's so I was thinking how to approach next. Should I go type 2, type 1, or switch to feeding 15 kilohertz for this tape? So I'm not sure yet. Probably gonna go type 2, type 1. No, you know what? I'm probably gonna do 15 kilohertz now and adjust bias on this side, and yeah, and then I continue with type 2 and type 1 of camera, because that's a lot of work. Even yeah, anyways, that's a lot of poking around because it's not type so not 3 header, so you have to like record, playback, adjust, record, playback, adjust. I did it literally 10 times in order to get this correct. So now this is correct. Now we're gonna do bias. So for the bias adjustment, we're gonna feed in 15 kilohertz minus 20 dB, which is 100 millivolts, which is actually handy written here, and record, rewind, and playback. And I have to adjust these potentiometers to make sure we get exactly the same 15 kilohertz on output. Let's do it. Alright, so I have applied 15 kilohertz, 77 mil. Essentially, I've divided my voltage which I was applying to the input to 10. So let's see what we got. We have to switch it to rack play. And we obviously not gonna see anything, but we got 103 millivolts. And I have to drop the All right, perfect. We have 103 millivolts, so that's good to go. You can actually tweak it a little bit here and here and here. Okay, perfect. Little like it's touch of the feather. So we have 103 millivolt. Now we have to record. Again, we counted 203 and then rewind and listen to what we got. So again, let me try that and see. Very tedious procedure, my friend. Very tedious procedure. It's probably as long as everything else before. I think that's plenty. And we need to tweak bias, looks like. So we got we got 68 millivolt and 64 millivolt on channel. So we have to tweak them over slightly. So we're gonna remove this and I'm gonna start tweaking. So now I'm gonna be tweaking on this side, which is probably even less handy. Yeah. I need to also identify the right potentiometers. So right here, whole bunch of potentiometers which you have to identify. So we need to look at 1 of 5 and 2 of 5 for ZX. So 1 of 5. Okay, so this guy's on the top, this is our guys. And looks like top is metal and then it just goes type 2, type 1. Okay, so we have to tweak those two guys. Again, I have no clue which way to tweak it, but I guess we have to start tweaking it before it goes somewhere. So we have to increase. So I turn it this way. Well, let's see what we got. And yeah, and process will be long. And I think I turned the wrong direction. So this is the problem. So you have to understand which way are you turning. So let me guys fix this and I will present you already like a tuned bias. Alright, so I've done this tedious procedure for this tape and looks like its level is correct and this is how it looks like on an oscilloscope. So now is even more tedious part to do the same with type 2 and type 1 cassette. That's gonna take some time, so guys, I'm definitely gonna be doing off camera, but the procedure is like this. 400 Hz, proper types here, then 15 kilohertz over here, and then probably switch your formulation or tape to another. So I'm not sure which one I'm gonna pick. I have a lot of these guys, not that many of these guys, so probably gonna pick Maxell XL. Because yeah, they are much more readily accessible, and prices of these guys new are insane in comparison to XL. So anyways, so I'm gonna continue and then at the very end I will show you my results. All right, my friends, finally, like, you know, hour and a half later, jeez, took forever, I have calibrated the last cassette, and this is type 1. I actually pick Maxell XL if you're wondering. Alright, so repeat above 5 or 6 or 3 times to obtain maximum performance. Okay, I repeated like 10 times each to obtain maximum performance. Okay, so now they're suggesting to feed 400 Hz and record, rewind and play it back. Check to ensure whatever the total harmonic distortion is less than 1% for the ZX tapes and 1.2 for SX tape. So this is kind of interesting. So I haven't played too much with total harmonic distortions, but let me do some experiments and I'll come back. What's the best way of doing this? Alright, I decided to cover the cassette deck with the lid, kind of hoping that will less distortions, but here we are. I got very interesting results. One channel has pretty much 1% distortion on the metal tape, another has 1.6, and I do not understand what is going on. So there is something probably checked electrically, or maybe I need to use another cassette. Maybe you know, the one of the tracks is kind of old and stuff, like, I mean, worn off, I mean, old. So let me try type 2 and see what we got. Alright, so I captured also THD for Maxella UR and Maxella XL2, and it seems like this is the best so far. Very nice response. Here is kind of weird. One side is good and not side. One channel is good, another is not so good. But yeah, you have to use like new tape in order to actually get good readings, because tapes can be mangled, skewed, scratched, and whatever. So I would recommend, if you have a bunch of nice and good tapes, use them for calibration. I am very stingy to use new tapes because I don't have many of them. Anyways, so I think we finished, and THD is okay. This is reasonable, I think. So I'm gonna stop at this and deem this a calibration success. Maybe when I have more time in my hands, I will actually poke around and with new cassettes and see if there is any problem electrically. Otherwise, we would have to take a look. Maybe there is a little bad capacitors or something like that, or capacitor is getting bad. But on this was actually everything fine. So I assume it's not capacitor or anything like that. This is just the tape. So one of the channels on tracks on a cassette was actually scratched, mangled, you know, creased or whatever. Right, so we have a success. We finished our calibration, and I hope that was very useful procedure for all of you. Yes, it was long, but took me a video would be probably long, but believe me, it took me like probably 5 times more time to actually go through the procedure. So guys, thank you for watching. Please comment if you see any have anything interesting ideas and anything you can comment on. We'll be happy to hear from you. Stay tuned for more videos. Stay safe and ciao.